Hippodromes were used for chariot races in the times of ancient Rome. Let's see if we can get Fusion to go around a modelled hippodrome. This is the outline program which we would use to send our Fusion robot around the hippodrome. The first thing we ignore is the 7 seconds wait here, which is just there so I can start filming. The rest is important though. This repeat, it goes through, it checks to see if the touch sensor is pressed. If it isn't, it wall follows. No touch sensor, wall follow. No touch sensor, wall follow. But if a touch sensor is pressed, then it turns left, and after it has finished turning left, it goes back to wall following again. And that's the outline program we would use. The wall following function is the same as we've used in previous videos, so we won't spend much time on this. The only things we've changed really are the light values here and here, which have been adjusted to try and keep the Fusion robot in the middle of each lane of the hippodrome. This is the function we would use to turn Fusion 90 degrees to the left. We know, first of all, that Fusion has already hit the end of the hippodrome because the touch sensor has been pressed. And so we'd use this first command to drive Fusion backwards a small distance to give us enough room to turn around. We'd then use the second command in this function to rotate Fusion around about 90 degrees, and these values that we found experimentally seem to work quite well. After that, we would drop out of our turn left 90 function, and the main program, we go back to line following again. This is our main program with the main program up here and the functions. The turn left 90 function in the main program corresponds to the turn left in the top right, and the wall follow in the bottom of our main program corresponds to the function in the lower middle part of the diagram. Okay, so let's run that and see what happens. We ran into problems. Okay, the wall following worked okay, but the optical distance sensor, which was sensing the wall, was spread out sufficiently in its detection ability that it started to detect the end wall before the touch sensor had touched the end wall. This meant the robot started to turn and it jammed in the corner. We tried lots of ways of adjusting the optical distance sensor, but nothing really was satisfactory. And so we ended up having to add extensions to the touch sensor, as you can see here. This is the extension piece we needed to add to the touch sensor of our Fusion robot. You can see we used a Lego cruciform or cross-section axis, and it's about 3 centimeters or 1 3/16 of an inch long. The axle will not go through the holes in Fusion. The holes are not quite compatible, so we had to use the grey Lego piece you can see there, which we bolted to the front of the robot, as you can see in this particular picture. Here we see Fusion going around our old hippodrome, touch, nice 90 degrees, parallel to the edge roughly again, and again there'll be a touch here, the blue for the touch sensor, and the wall follow again. You'll notice this our hippodrome is a very old set of tiles which can be changed to all sorts of different types of mazes. Here we come up to a road again, a nice conversion. We originally produced these in 2008, and Yaya produced them more in 2011, as you can see in her nice turn again, her YayaLou.net, and they've survived very well actually. They've been to a lot of schools in the meanwhile, and they're still sort of working. They really need repainting, but in the meanwhile you'll notice that Fusion is going around here quite nicely. The extensions we've got on the touch sensor permit the touch sensor to work before the optical distance sensor is confused by the end of the Hippodrome. Good.